So in this today's class, let us try to solve few more problems related to the concepts which we have already learnt in our earlier classes. So here is the first question. A light of wavelength 6000 Armstrong in air enters a medium with refractive index 1.5. Here he is giving the wavelength of light. So it is 6000 Armstrong. So this wavelength of light enters a medium which has got the refractive index 1.5. So he is asking what will be frequency and wavelength of light in the medium. So here we need to find what can be the frequency or what can be the wavelength of this light when this light enters the medium of refractive index 1.5. So here we have the given data. Lambda here denotes the wavelength of light, that is 6000 Armstrong. Next you can convert 6000 Armstrong into 6 into 10 power minus 7 meters. So you can keep lambda in terms of Armstrong as well. So no issues. You can convert this 6000 Armstrong to 6 into 10 power minus by taking these 3 zeros in 6000 and multiplying that to Armstrong value. The factor for Armstrong is 10 power minus 10. If 10 power minus 10 is multiplied with 10 power 3, then it will be 10 power minus 7. So 6000 Armstrong is equals to 6 into 10 power minus 7 meters. Next, the refractive index of second medium is given. It is 1.5 and the refractive index of first medium is known to us because in question he has mentioned a light is travelling from air to refractive index of 1.5 medium. So from that it is clear that a ray of light is travelling in a refractive index medium which has got the value 1. So we have N2 1.5 and N1 1. So here when light travels from one medium to another medium, that is from air to a refracting medium, the frequency of light does not change. So frequency remains same. So nu dash can be given as nu is equal to c by lambda. Here c denotes the velocity of light in vacuum and wavelength is denoted by lambda. So we know the value of c is 3 into 10 power 8 meters per second divided by the lambda value, that is 6 into 10 power minus 7 meters. So here meters will get cancelled, what remains is per second. So if you solve 3 into 10 power 8 divided by 6 into 10 power minus 7, then you will get 5 into 10 power 14 per second. So the frequency of light when it travels from air to a refracting medium has the value 5 into 10 power 14 per second. Now let us find the wavelength of light in the medium. So the equation to find the wavelength of medium is equals to lambda by N2. So that gives the lambda prime, that means the wavelength of light in the medium. So lambda here the wavelength of light in air medium and lambda dash here is wavelength of light in the medium. Now we know the value of lambda, it is 6000 Armstrong divided by N2, it is 1.5. So if you solve this, you will get 4000 Armstrong. So lambda prime is 4000 Armstrong. So if you observe, the wavelength of light in medium is less compared to wavelength of light in air medium. So lambda is not equals to lambda prime, whereas lambda prime is less than lambda. Now the second question is the refractive index of glass is 1.5 and that of water is 1.3. So the refractive index of both medium is given to us. The refractive index of glass is 1.5 and the refractive index of water is 1.3. So if you see, glass forms the denser medium compared to water. If the speed of light in water is 2.25 into 10 power 8 meters per second, what is the speed of light in glass medium? So he has given the speed of light in water, that is 2.25 into 10 power 8 meters per second. So now our turn is to find the speed of light in glass. So the data here is Ng, that is refractive index of glass, is 1.5 and W, refractive index of water, is 1.3. Vg is, we have to find, Vg is velocity of light in glass medium and Vw is given 2.25 into 10 power 8 meters per second. So Vw here denotes velocity of light in water medium. So from the data, if we write the equation, so we know absolute refractive index can be given as the speed of light in vacuum to speed of light in a medium. So using that absolute refractive index formula, we will write the equation for Ng and Nw. Ng is equals to C by Vg and Nw is C by Vw. So here we got two equations for Ng and Nw. So wherein we know the value of C and we know the value of Vw, we have to find the value of Vg. If you substitute all which is given in the question, then you end up getting 1.5 is equals to C by Vg and 1.3 is equals to C by Vw. Now if you take the ratio of Nw by Ng, then you will get 1.3 divided by 1.5, which is equals to C by Vw multiplied by Vg by C. Here two terms C and C gets cancelled because one is in numerator and another one is in denominator. So what left is Vg divided by Vw, which is equals to 1.3 divided by 1.5. So from the data or from the question we know what is the value of Vw. Substitute the value of Vw in the above formula. So Vg will be equals to 1.5 divided by Vg is equals to 1.3 divided by 1.5, which is multiplied by 2.25 into 10 power 8. So Vg can be written as, if you solve this mathematics, then you will get Vg is equals to 1.95 into 10 power 8 meters per second. So if you compare Vg with Vw, then you will see Vg is less, that is velocity of light in glass medium, that is denser medium, is less compared to velocity of light in water medium. So here water medium has got less refractive index in comparison to the refractive index of the glass medium. Hence Vg is less than Vw. So in next section we will be solving few problems on spherical refracting surfaces. Before doing that, let us understand 2 points on this spherical refracting surfaces or the formula on spherical refracting surfaces. So here are 2 points. The first point says, in case the object is situated in rarer medium, so that incident ray travels in rarer medium and refracted ray travels in denser medium, then relation between u, v, r, n1, n2 can be given as minus n1 by u plus n2 by v, which is equals to n2 minus n1 by r. So the object is placed in a rarer medium and the light from this object travels from rarer medium to the denser medium. So if that is the case, then the equation will be minus n1 by u plus n2 by v, which is equals to n2 minus n1 by r. So, this is the relation that you have to use when object is placed in a rarer medium. So, note 2 here is, in case object is situated in denser medium, so that incident ray travels in denser medium and refracted ray travels in rarer medium, then the relation between u, v, r, n1 and n2 can be given as. So, here object is situated in denser medium and the image will be formed in the rarer medium. So, that is light is travelling from denser medium to rarer medium. Then light ray bends away from the normal and towards the surface. So, in that case the relation can be given as minus n2 by u plus n1 by v, which is equals to n1 minus n2 by r. So, in last case you saw minus n1 by u was there. So, if you observe here, it is minus n2 by u plus n1 by v, which is equals to n1 minus n2 by r. In last case it was n2 minus n1 by r, here it is n1 minus n2 by r. So, this is the second point in note. The factor n2 minus n1 called power of spherical refracting surface. So, the factor which we saw in above two equations, that is n2 minus n1, can give the power of spherical refracting surface. Now, what is the power of spherical refracting surface? So, it gives the measure of the degree to which refracting surface can converge or diverge the rays of light passing through it. So, if you incident a light ray on the convex or concave refracting surface, then this factor will give how much the light rays gets converged or how much the light rays gets diverged when they falls on the spherical refracting surface. So, it is n2 minus n1 by r. Here n2 is refractive index of second medium and n1 is refractive index of first medium. R is the radius of curvature. So, the first question here is, a small point object is placed in air at a distance of 60 centimeter from the convex spherical refracting surface. So, object is placed 60 centimeter from the convex refracting surface, which has got the refractive index 1.5. If radius of curvature of the spherical surface is 25 centimeter, calculate the position of image and power of the refracting surface. So, here he has given the value of u and value of n2. He is asking us to calculate the value of v and the value of power, that is p. So, from this question, what will be the value of n1? N1 will take the value 1 because a small point object is placed in air. So, N2 is 1.5. The given data of this question is u is given, r is given, N1 we know, N2 is 1.5. So, the value of u is taken as minus 60 centimeter. Why? Because we are measuring the length or the distance of u, which is opposite to the direction of incident ray. So, we are taking the value of u as minus 60 centimeter. So, if you observe r value, r here is plus 25 centimeter. So, this value is measured in the direction of the incident ray, hence the value of r is positive and value of u is negative. N1 is 1 and N2 is given in the question, that is 1.5. So, now if you substitute all these values in the given equation, here the light ray is travelling from air medium to the denser medium. So the equation here will be what? N2 by V minus N1 by U, which is equals to N2 minus N1 by R. So we know the value of N2, that is 1.5 minus 1 divided by minus 60 is equals to minus 1.5 minus 1 divided by 25. So this can be written as 1.5 divided by is equals to 0.5 divided by 25 minus 1 by 60. So if you solve this equation, you will get the value of V. The next is, so 1.5 divided by 1 is equals to 1.31 divided by 300. So if you solve 0.5 divided by 25 minus 1 by 60, then you will get 1 divided by 300. If you cross multiply these two equations, then you get V is equals to 300 multiply 1.5. So V is equals to 450 centimeter. So here the value of V which we got is positive. So if V is positive, real image will be formed inside the refracting denser medium, so which has got the value 1.5. Since V is positive, we can say that the real image is formed inside this denser medium. So now let us calculate the power of refracting surface. We know the equation for P is equals to N2 minus N1 by R. So R is known to us. So here R is in 25 centimeters. Convert this to meters. So 25 centimeter is equals to 0.25 meters. Substitute the values in P. 1.5 minus 1 divided by 0.25. So P is equals to 0.5 divided by 0.25, which will give the value of P as 2 diopter. So in this question we found what is the image distance, that is V, and we also found what is the power of this spherical refracting surface, which has got value 1.5 for refractive index. Now the next question is, what curvature must be given to the boundary surface of a refracting medium n is equals to 1.5. So he is asking R value, what curvature. So now for virtual image of an object in the adjacent medium. So adjacent medium has got the refractive index n is equals to 1. So from this we can say the n is equals to 1.5 is a glass medium and n is equals to 1 is the air medium. Next, at 10 centimeter to be formed at a distance of 40 centimeter. So here U object distance is 10 centimeter and V image distance is 40 centimeter. We have to find the radius of curvature for these values. From the question, n1 is equals to 1, n2 is equal to 0.5, U is equals to minus 10 centimeter. Why it is minus 10 centimeter? Because we are measuring it in opposite direction. V is again minus 40 centimeter. So now we have to calculate R value. So to calculate that, let us substitute all the data which we have got from the question in the equation. Minus n1 by U plus n2 by V, which is equals to n2 minus n1 by R. So n1 value is 1 divided by minus 10 plus 1.5 divided by minus 40, which is equals to 1.5 minus 1 divided by R. So this will give the value as 0.5 divided by R is equals to 1 by 10 minus 1.5 divided by 40. So if you solve, you will get R. So 0.5 divided by R is equals to 0.1 minus 0.0315. So R can be written as 0.5 divided by 0.1 minus 0.0375. So R is equals to 8 centimeter. So radius of curvature for this spherical refracting surface should be 8 centimeter. Next question here is, a spherical surface of radius of curvature R separates air which has got the refractive index n is equals to 1 from the glass medium which has got the refractive index 1.5. The center of curvature is in the glass medium. A point object P placed in air found to have a real image in the glass. So, object is P, so it is placed in an air medium, and after refraction the real image is found in the glass medium. So, that is Q. The line PQ cuts the surface point O and PO is equals to OQ. Find the distance of object from the spherical surface. So, here is telling the line PQ cuts the surface, it cuts the glass surface at point O. So, if this PO is equals to OQ. So, from this question we have to find what is the distance of object from the spherical surface, or U we have to find. To calculate U, we need to first draw the diagram for the above question. So, here it is the spherical refracting sphere. So, on this sphere the principal axis passes at the center of the curvature C. So, there is an object at point P. So, light from P travels in a rarer medium and hits the sphere at point A. So, from this point A, a normal line is drawn, so which passes through the center of curvature. So, after when this line or when this incident ray hits at a point A, then there will be the refraction that occurs due to the variation in the refracting index of the. So, the refractive index of the medium where our object is lying is less compared to the refractive index of the medium where the image is formed. So, since the incident ray is travelling from rarer medium to denser medium, then the light ray bends towards the normal away from the surface after refraction. So, here PA is incident ray and AQ is refracted ray and AC is normal drawn at the surface. And if light ray passes from the center of the curvature, there will be no refraction and this ray meets the AQ ray at point Q. So, the distance of PO is object distance which is denoted by U, and OC distance is R which is the radius of curvature. OQ is the image distance which is given as V, and the refractive index of this sphere is 1.5. So, in the question it is given that Q cuts the surface at point O. So, if this happens, then PO is equals to OQ. That means image distance is equals to the object distance which is kept at point P. So, now from all these data which is given in the question, let us try to find the object distance, that is U. So, the refraction takes place from rarer medium to denser medium, that is light ray, incident light ray is travelling from rarer medium to denser medium. So, we can write the equation, that is minus 1 by U plus n by V is equals to n minus 1 by R. So, from the question U and V are equal, that is PO is equals to OQ. So, if you take same magnitude, so let's suppose if U is equals to X, then V should be equals to X. Since we are measuring the distance U opposite to the direction of incident ray, we can take that as minus x and v will be positive x. Substitute all this in the above equation. So, minus 1 by minus x plus 1.5 divided by plus x will be equals to 1.5 minus 1 divided by r. So, now let us try to solve this equation and find what is x. Here r is again unknown to us, the value of r is not given in the equation. So, here x and r, two variables are unknown to us. So, let us solve this equation. So, minus 1 divided by minus x plus 1.5 divided by x is equals to 1.5 by 1.5 minus 1 divided by r. Now, this 0.5 divided by r is equals to 2.5 divided by x. So, here minus 1 divided by minus x, here minus minus will get, what remains is 1 by x. So, if you subtract, or so here you have to add, so minus minus gets cancelled and what remains is plus 1 by x. So, if you add 1 by x to 1.5 by x, then you will get 2.5 divided by x. So, if you cross multiply now, so x 0.5 multiplied by x will be equals to 2.5 multiplied by r. So, now we want the value of u, that is object distance. So, x can be equals to 2.5 divided by 0.5. So, 5 is 25. So, x is equals to 5r. So, the image distance for this problem needs to be 5 times the radius of curvature of the sphere. So, to solve this problem, we first have to understand the ray diagram. So, before solving this problem, try to understand how the ray diagram is, how the incident ray is, how the refraction ray is, and what is the data which is given in the question. So, in the question he has clearly mentioned that image distance is equals to object distance, but by sign convention we have to take image distance as negative value and object distance as positive value. So, if you take both the u and v value as x and x, then you end up getting the wrong answer. So, the sign convention is equally important while solving the problems in optics. So, if you are clear with drawing the ray diagram, then half of the problem will be done there itself. So, here we have solved this problem and we found the value of u and value of v as 5r. So, u will be minus 5r and v will be plus 5r. So, this is the last problem. Hope this unit and the problems based on this unit is clear to you all. In the next class, I will start the second unit, that is cardinal points of an optical system. So, if you have any doubts, then you can comment in the comment section.